Okay, hello everybody. This is Miss Pie, of course. I've heard some people say that I'm too monotone in my videos. I will try to show more expression or I guess make more sounds. Like I'll try clearing my throat. Maybe I'll try burping. I know my 14-year-old can burp the alphabet backwards, so that's kind of impressive. Maybe I'll have him get on sometime. Anyway, for right now, I just wanted to shoot this video to give you guys a little bit of help on your homework this evening. Where most of us left off in class, you had to find this series of the first 5 terms in the first 3 sequences we looked at today. And yes, I know that you guys could just add these all up and get your terms or get your series, but I wanted you to practice using the geometric series formula and using the sigma notation. I am aware that many of you do not have a calculator at home, so you can either go online and find a graphing calculator, and you should be able to find the sigma notation somewhere on there, or come by my classroom tomorrow morning bright and early and use the calculator to find the sigma notations for the 2 sequences that you're going to use sigma notation on. So let me just walk you through a couple of these. So this one here, this was the first one, and we want to find the series of the first 5 terms. And so if we plug it into our calculator, let me move my calculator over. All right, so I'm going to plug it in, and I always like to use the fraction button whenever I have a real big complicated fraction like this. And that just helps me keep everything in the numerator that's supposed to be in the numerator and everything in the denominator that's supposed to be in the denominator. All right, so I'm going to have, for this one, the series of the first 5 terms will be my first term times 1 minus my rate. And in this case, we found out that our rate was 10, and that's raised to the 5th power. Okay, notice the 5 is inside the parentheses. I have seen in homework where the 5 was outside the parentheses, and I'll just show you some cautions, things to help keep that exponent inside. Okay, so this is our fraction. We push enter, and you can't see the answer. There's the answer. So for S sub 5, the answer is 277.775. Okay, so over here, I'm going to put down that I'm using my mouse pad, so yes, my S's do look like 5s. Sorry. So S sub 5, so this series of the first 5 terms was 277. Oh man, that looks like a terrible 7. Sorry guys. 7.75. To save us some more misery, I'll just put an 8 there. Okay, usually I want you to round to 2 decimal places, but it's really hard to draw these numbers on the mouse pad on my computer. And I suppose I probably could find a mouse and it would be easier, but then I'd have to pause the video. And you guys don't want me to pause the video, right? Okay, so let's go on. So the first part was to find this series, S of 5 here, and this one, and this one. And then you were supposed to use the 2 geometric sequences that you created and find the first 5, or to find what the total is of the first 5 terms. And yes, I know I gave you instructions that were contrary to what the textbook said. So in the textbooks, it says give the first 5 partial sums. So what the textbook wants is S sub 1, S sub 2, S sub 3, S sub 4, and all the partial sums for all 5 of the sequences. So guys, that's like 25 answers all on that little tiny piece of or section of the worksheet. You're not going to have enough space to write all those answers down. So I don't want you to find S sub 1, S sub 2, S sub 3, S sub 4, and S sub 5. Just find S sub 5 for me, okay? That's all I want, because one of the other problems wants you to find the sum of the first 100 terms. So then you can do S sub 100 and then compare those answers. Okay, so in our first example, way over here, whoops, went too far. So this was F sub 5. So if I wanted to find S sub 100, let me very carefully try to draw these zeros. Oh, got it. All right, so if I want to do S sub 100, everything on this equation here is going to be the same except for the 5 right here. I'm just going to replace that with 100. So I take this 5 out and put 100 there. So in the calculator, since I already have this on my calculator, I'll come up, highlight it, push enter, and then I'll go up here, go to my exponent, delete it, and push 100. Okay, I push enter, and holy cow, I don't expect you to write 97 zeros. And then, you know, that's crazy. Okay, just give me the scientific notation. So basically with this sequence, this is kind of hard because it's, I don't know what this thing is, but it won't like disappear. It's always in the way. Anyway, so with this sequence, notice how we have 2.77778 and we have 2.77, and I think originally it was 775. So you notice how we have the same initial numbers, but we're going to move the decimal 97 times that away, okay? So it's going to, I couldn't even tell you what number that is. That's such a large number. So basically what I want you to realize is that if the sequence diverges, notice that my R value is 10, then my series is also going to keep going, and eventually it will get to infinity. It's not going to approach some number, it'll just get to infinity. Now when we look at this one, remember this example, our ratio is a fraction, so it's less than 1. And we said that it converged and all these terms got closer and closer to 0. Okay. Well, when I use the, I'm going to use sigma notation with this one. You guys don't have to. Let's see. I'll try a K. There's my K. Sorry, it looks like a crooked X or I don't know. Sorry about that. Anyway, I'm going to use K and then my parentheses. 100 is my A sub 1. Remember, right here you need to use the sequence formula, the geometric sequence formula. And my rate is 1/2. And then parentheses, that's raised to the K minus 1 power. Woohoo, let me get this. K minus 1. All right. And then that's all in parentheses. And then in this case, to find the 5th term, this would be a 5. When we wanted to add up all the first 100 terms, I would put 100 up here. All right, so let's see what's happening with this. So if I use my sigma notation right there, here I'm going to do K equals 1, and then up here I'm going to have a 5. Then in this box I have my first term 100 times 1/2 raised to the K minus 1 power. Where's my K? There's K minus 1 power. All right, let's go ahead and push enter and see what happens. Okay, notice how what happened with my exponent. I get this weird thing here, and it's because I was not careful with my parentheses. Notice when I was drawing it over here, I had parentheses around my fraction. So the reason why I wanted to show you that is because I've actually seen a lot of your homework where you've typed it in like that, and then you're going to get the wrong answer, okay? In this case, I honestly don't know if it's giving me the right answer or the wrong answer, so let's retype it in, but put the parentheses where they go. All right, so I'm going to just get rid of all that. I'm going to do 100 times, and now open parentheses, 1 divided by 2, or 1/2, close parentheses. Now I'm going to raise it to K minus 1, and then push enter. Let's see how that changes. Does it change? In this case, it may not, yeah. So in this case, in this example, it did not. However, There are some times when it will. For instance, if I was using the series formula and I had 1/2 here, then a lot of times the calculator will automatically like put a closed parentheses here, and you would have like the 5 on the outside of this parentheses. It's really weird. Honestly, I don't know what or how the calculator decides sometimes on where to put the parentheses or not. But in this case, just make sure you have the whole thing in parentheses. All right, so let's see. So we had 775 over 4, and that's kind of a nice number, but if I'm comparing it to the first 100 terms, I would like to have a decimal. Sorry, let me get a drink. All righty, that was just a drink of water, just so you know. All right, so let's go ahead and check out the series or the sum of the first 100 terms. And I just need to change this 5 to a 100. Okay. Holy stinking cow, this big, huge, crazy fraction. Well, let me put it in, approximate it to a decimal. And notice my initial, if I add up the first 5 terms, I get 193.75. If I add up the first 100 terms, I only get $200 or 200. I don't know why I said dollars. This isn't money. Sorry, guys. Anyway, so if I add 95 more terms, I'm only increasing the total by what? About $6.26. Oh my goodness. I have money on the brain, guys. So everybody needs to bring me money tomorrow, okay? Anyway, it only increases it by 6.25. Okay, so let's see what would happen if we go ahead and extend this to the first 1,000 terms. How much bigger is it going to get? Well, my fraction is going crazy. Oh man, what did I do? Let's go back here. So yeah, my fraction is going crazy. Let's go ahead and convert it to a decimal. Oh wait, it's only 200. Okay, so what you'll find is, remember the infinite geometric series formula that I showed you in class today? We're going to find that when our rate is a fraction that's less than 1, then we can use that infinite geometric series formula, which is, we have a fraction, okay, and you put your a sub 1 up here. So my a sub 1 in this case was 100. That's my a sub 1 right there. You could also see it right there. There's a sub 1. It was hiding. Sorry. So we have this fraction, a sub 1 divided by 1 minus our rate, and in this case the rate was 1/2, and we push enter and look, it's 200. So whether we do these series formulas with huge numbers up here, or we use the infinite geometric series formula, we still get the same answer. So eventually the series, so the terms are getting closer and closer to 0. The terms in the sequence are getting closer to 0. But the series gets closer and closer to 200. S-E-R-I-E-S. Sorry. Hold on. It's so difficult thinking and talking and spelling words out at the same time. So the terms converge to 0. The series converges to 200. Okay. All right. So that's just basically what they want you to be able to see as you're adding the first 5 terms and adding the first 100 terms. So this one, because the terms diverge, this series also diverged. So as you get bigger and bigger numbers, your answer is going to eventually get to infinity. I won't wait around for you to get to infinity, but eventually, if you kept on working on it, it would get to infinity. Okay? When your rate is a fraction and it's geometric, then the series will approach some number, and in this case, it approached 200. Let's see what this one will do. I'm going to let you guys do the homework on that one. Find the series formula, or use either the series formula or sigma notation. Find S sub 5. Whoops. Let's get the 5. figure out what S sub 5 is for this and what S sub 100 is for this. Oh my gosh, it's so hard to draw zeros. There we go. They look kind of scary. Sorry. So find the series for this and then the two equations that you created and see if you can see which ones that you could potentially use the infinite geometric series with and which ones you can't. Okay. Let's see. I think that was all that we wanted. Yep. Okay. I think this was, we never got to this. If you feel like doing this for homework, you can. You don't have to. It just is more practice on using the infinite geometric series formula. All right. I hope you guys were able to understand more of what we were doing today in class. And don't freak out if you don't have a graphing calculator at home. I've been told by a lady that works for TI Nspire that we will have TI Nspire calculator, not actual the calculator itself, but software for your computers at home where you can upload the calculators. That's coming soon. I hope it gets here really, really soon. All right, see you tomorrow. Bye.